For my project, I wrote a Perudo game, an interactive Perudo game using plog for the AI. I had to change the rules slightly to accommodate plog's performance, but it's still playable and still works. Also, a lot of work was done, or some work was done, to modify plog to make use of Klingo as opposed to S models. That was to improve performance. Okay. We'll open up here and see the interface. Hi. The scene here is a scene from a game called Red Dead Redemption. It's a game where you play Perudo as a mini game. So I use that for the background. Alright, so the way the game works is everybody rolls dice here. There's 4 players, including me. And we're using 3 dice apiece. Everybody rolls their dice, keeps them secret, and each players take turns guessing how many of a certain number they think are out there, and each guess has to go up in quantity or suit, and you'll see that as we go along. So I'll make my first guess. I'm going to think there are, or guess there are 3 twos, at least 3 twos. So I'm going to guess. The next player will either make a higher guess, a larger wager, or call Perudo on me. That means they think I'm lying. They think that I don't have those dice, or that many dice aren't out there. So they think there are 4 twos. So the computer, the plog actually takes into account the previous plays. So they don't know what each person has, but they do take into account what they guessed. So for example, I guessed 3 twos, so they will assume that I have at least 1 2 and take that into account, and so on and so forth. So this person guessed 5 twos, so that means they think there are 3 twos out here. That's reasonable. So I'll go ahead and I'll move it up with 6 twos. I'll probably be wrong. We'll call Perudo on them. Call Perudo. So I was wrong. There were 5 twos. So whenever you call Perudo, it reveals everybody's dice. So I'll lose a die since I was wrong. So we'll click continue. So I'm down to 2 dice. So let's guess 3 threes. Right. So while this is going, we can actually look and see. We'll look at the most recent. So I write the plog files to the temp directory. So we'll look at the most recent plog file. So here we can see the specification for success. Success given all of these observations. And these observations encode the person's current dice and the people that have gone before them, the players that have gone before them. Right, we see there's 11 dice. They can only be 1 through 3 in suit. That's due to performance, and we have 4 players. Right, this is actually the condition for success. This is checking to see if there are, it looks like, the probability of 4 threes. So it's checking to find, so success is if there are 4 threes. So we have D1 is equal to 3, and D1 is not equal to D2. So we have 4 different dice. D2 is equal to 3, D3 is equal to 3, and D4 is equal to 3, and that all the dice are different. So what we're checking here for is that there are 4 different dice that have been rolled a 3. Alright. You'll also see here that I'm using Klingo. So the output that's actually read into Klingo we can see here. So this is the output of plog that's read into Klingo. I had to make a couple of accommodations for the way that plog was outputting the files. So one of them is using, defining what not equal. NEQ was used in S models. It was just quick to add NEQ here. Also changing the way the hides and shows worked. Alright. I bet, yeah, it looks like, so the third player called Perudo and was wrong. So the way Perudo works, we'll probably see this here. So the way Perudo works, how a player will call Perudo. So the actual logic at work here, in the game logic is handled in C sharp, and the way that works is the player will, or the player going will check all of the next possible guesses. So either incrementing the suit by one or the quantity by one. Check the probability of each of those using plog, and also check the probability of the last person's guess, taking into account only the information they know, and check how likely that is, or how likely that is not to happen, and then chooses the one with the highest probability, or one of the ones with the highest probability. It arbitrarily chooses one if there are some with equal probability. So that's how the AI works. As far as the interface, we can keep playing here. So player 2 will lose a die. So they're down a die, and we'll keep going. I'll go ahead and finish up the game so we can see how the game works and finishes. I can see more temp files being made. These are more plog programs being made to check. So a plog program is made each time a check, for each case that has to be checked. Currently, 4 players total with 3 dice apiece. 3 3-sided dice is the best that I can get to work in a reasonable amount of time. And in fact, if the quantities get up higher than 5 or 6, then it really becomes too slow. You've got to wait quite a while. I have the timeout right now on, I believe, 2 minutes, and every now and then it'll hit 2 minutes. So player 3 just hit 6 threes. I'm gonna call Perudo on that, and they were wrong. There were only 4, but you see there were a lot of threes floating around out there, which is why people were, or the computer was willing to take it up that high. Okay, so we'll continue 1-1. I'm gonna guess 3 ones. Okay. Player 1 lost a dice, so we're all down to 2. And it performs, it goes much quicker once the dice get down quite a bit. So 1, 2, 2, 2, 2, 3. Oh, I have 2 ones again. We'll go 3 ones. Oh, I was wrong. I will guess 2 twos. I'm probably going to be out this one. The computer is surprisingly hard to beat, I guess, which is a good thing. Yeah, so I'm actually out now. I guess 4 threes. I didn't think that was possible. Very likely, at least. Okay, so now we'll actually see the computer playing against itself. And whenever somebody loses, the player still has to click continue. So it'll go until there's only one person left, only one person with their 1 die, or I guess multiple dice, but down to 1 person, and the game will end. Oh, so that player's out, so it's between these 2. Oh, 2 people left. Oh. Well, that person's out. Alright. Real quick, we can go over and look at the C# project. So here it's accommodating a lot of players and a lot of dice. it's just taking that into account. What we can look at is the where the flow to actually call plog. So the game engine has an action called, or a method called make AI move. That'll take us to progress turn. No, it'll get us a new guess. No, that's make player move. Make AI move. Will take us to get guess, and this will actually be what calls plog. So here we go. We have a query plog. This is the for loop going through in all of our possible combinations, and this is where it's actually querying plog. Here we can see the query for Perudo. If somebody else is gone, it queries for Perudo. So here we're actually calling plog. So here we are writing all of our observations, filling in all our data, making our plog file, writing our plog file, and here we're actually calling plog. So I call it command line. I pass it the plog file, and actually we'll go up here to execute. I actually intercept standard out. So here we see output reader, and I actually intercept standard out to using C#'s process libraries. And that's how I'm interfacing with plog. So that's the game. It's working using plog. The only changes that I've looked at making going forward is actually in the plog source code. I've looked at improving the performance of plog. It uses a partial grounder that actually, what they call a partial grounder, that calculates the probabilities on the fly, as opposed to calculating all the answer sets and then the probabilities, which shows promise at being a lot more efficient. I just haven't, the code base is kind of nasty and I haven't had time to dig any deeper into that. But that's it. Let me know if you have any questions.